An operating system is one of the most important pieces of software ever created, yet most people use one every single day without really knowing what it does. Windows, Mac OS, Linux, Android, and iOS all look very different on the surface, but at their core, they exist for the same reason: to make computers usable by humans. In the early days of computing, there were no operating systems at all. In the 1940s and 1950s, computers were massive machines that filled entire rooms, and programming them meant manually rewiring hardware or feeding in stacks of punch cards. Each program ran alone, and when it finished, the machine simply stopped. There was no screen, no mouse, and no multitasking. These machines were powerful for their time, but extremely inefficient and difficult to use. As computers became more common in universities and research labs, engineers realized they needed a way to manage hardware automatically. This led to the first operating systems in the late 1950s and early 1960s. These early systems handled simple tasks like loading programs into memory and scheduling jobs one after another. Over time, operating systems evolved alongside hardware, eventually becoming the invisible backbone of every modern device. So, what exactly is an operating system? At its simplest, an operating system is the middleman between hardware and software. Your computer's hardware, the CPU, memory, storage, keyboard, screen, and mouse, is powerful but useless on its own. Applications like browsers, games, and video editors also can't directly control hardware safely. The operating system sits in between, managing resources and making sure everything works together smoothly. One of the most important jobs of an operating system is process management. Every time you open an app, the operating system creates a process for it. If you are listening to music, browsing the web, and downloading a file at the same time, the operating system rapidly switches the CPU between tasks. This happens so fast that everything feels like it's running simultaneously, even though the CPU is only doing one thing at a time. Another critical role is memory management. Your computer's RAM is limited, and multiple programs compete for it. The operating system decides how much memory each program gets and prevents applications from accessing memory they don't own. Without this protection, one buggy app could crash your entire system. Modern operating systems also use virtual memory, allowing programs to use disk space as extra memory when RAM runs low. The operating system is also responsible for file management. Files on your hard drive or SSD aren't just random data. The OS organizes them into folders, keeps track of their locations, and controls who can access or modify them. When you save a document, the operating system decides where it goes physically on the disk and how it can be retrieved later. Then there's device management. Your keyboard, mouse, printer, camera, and USB drive all speak different hardware languages. The operating system uses device drivers to translate between hardware signals and software commands. This is why you can plug in a new mouse and have it work instantly. The OS already knows how to talk to it. What makes operating systems truly powerful is that they abstract complexity. Developers don't need to know how specific hardware works. They simply ask the operating system for resources. Want to display something on the screen? Ask the OS. Need to save a file? Ask the OS. This abstraction is what allows the same application to run on millions of machines with different hardware configurations. Over time, different types of operating systems evolve to serve different needs. Desktop operating systems like Windows, Mac OS, and Linux are designed for personal computers. They focus on multitasking, graphical interfaces, and compatibility with a wide range of software and hardware. Mobile operating systems like Android and iOS are optimized for touchscreens, battery life, and sensors like cameras, GPS, and accelerometers. They aggressively manage background apps to save power and protect user privacy through sandboxing. Server operating systems prioritize stability, security, and performance. Many servers run specialized versions of Linux or Windows Server, designed to handle thousands or even millions of simultaneous users without crashing. Embedded operating systems run inside devices you might not even think of as computers: cars, smart TVs, routers, washing machines, and medical equipment. These systems are often lightweight and designed to perform a single task reliably for years. Despite their power, operating systems have limitations. They are incredibly complex, often containing tens of millions of lines of code. This complexity makes them difficult to maintain and secure. Bugs and vulnerabilities are inevitable, and attackers constantly look for weaknesses to exploit. Operating systems also consume system resources themselves, meaning some computing power is always spent on management rather than user applications. Another challenge is compatibility. Supporting old software while adopting new hardware is a constant balancing act. This is why operating system updates sometimes break older programs or devices. Even with these challenges, operating systems continue to evolve.
Modern systems are becoming more secure, more efficient, and more intelligent. Virtualization, containers, and cloud computing all rely heavily on operating system technology. As devices become smaller, faster, and more connected, operating systems quietly adapt to power everything from smartphones to supercomputers. In the end, an operating system is not just software, it's the foundation that makes modern computing possible. If you enjoyed this explanation and want more clear breakdowns of how computers really work, watch the next video and don't forget to subscribe.